Welcome to this inaugural session, which we are trying to outreach to all institutions of higher learning. This will be the first one of a number of series to come, and I'm really honored and warmed. My heart is warmed that so many of you have expressed interest to join in. Today we have lined up a few talks which are really exciting, and I hope that you can somehow find relevance in your teaching agenda as well as in your research areas, that you can find ways in which high performance computing and the use of a supercomputer. Currently we have 31,000 cores and 13 petabytes of storage. So you can imagine if you have access to such powerful computing resources, what will happen if when we have our next upgrade, which should be up and running next year, with at least 5 to 10 petaflops of computing power. We are here to support all of you in your research work, to support you in your educational mission, and we are indeed honored to be part and parcel of the national research infrastructure from the National Research Foundation in order to enable all of you to do your work better, faster. Thank you.
All right, thank you, Prof. Tan. And my name is Bernard. I'm the Director for Strategy Planning Engagement for NSCC. Okay, I would like to thank everyone for your precious time. I know we're very excited to actually bring you this session. As what Prof. Tan had earlier mentioned, it's one of the many sessions. Today is actually built more based on the curriculum of your school. Now, on the 23rd September, we are going to do one more, but it's more for economic social science, okay? Which we will be joined by colleagues of SMU, SUSS. But all of you will be invited again if you're interested to join that course. That is built more for their curriculum. But it is great. And this is not just going to be a one-off engagement. This is actually a journey that we would like to partner you in your enablement session itself towards high performance computing and high-tech knowledge itself. Now, after this enablement, we will be also inviting you to join our Deep Learning Institute courses, okay, where we will go deep dive into topics like AI. Okay, this is going to be a self-learning online courses, and we will be working with each of your school main contact point to get nominations out of there. At the same time, we will also be sharing with you some interesting framework that you could actually take forth to your schools and your students as well. Example, AI competition, hackathons, that you can use it as a template or example to engage your student to actually embrace HPC plus AI as well, you know. And obviously come to year end, we will also be doing another train the trainer session, which we'll be sharing with you shortly, where you get certification out of this. So there's going to be an interesting journey where we will be sharing with you. Now, today, I am very excited to have two experts in their respective field. The first up is actually MSc Hexagon. They help industrial manufacturers to develop disruptive technology of today and life-changing products of tomorrow. So we have the privilege of Khatib here. He's the expert in experimental and computational fluid dynamics, specialized in the areas of high-speed flow and aerodynamics, as well as special interest in electrothermal and bio research itself. So he is actually a very experienced researcher himself on that basis. At the same time, from NVIDIA, you guys will probably know NVIDIA very well. They are one of the AI experts. NVIDIA provides the computational engine that makes possible for researchers, scientists, and creators to do their life work, from simulation of molecular interaction for drug discovery to creating imagery worlds in movies. I was very impressed with their work in Hollywood movies as well. And also developed AI for self-driving cars, robotics, and conversational search engine. Today, we're joined by Nicholas Walker, who is actually a senior solution architect for NVIDIA. He looks after the Southeast Asia customer around in Southeast Asia, in data centers, workstation solution, for the areas of high performance computing, deep learning, virtualized desktop, and professional graphics on that basis. Now, to kick us off, let me set the stage on that basis. Now, COVID has done what many government officials, CEOs, found hard to do: accelerate digitization. Now, government officials and business executives all have vital roles to play in guiding their country and organization to function effectively through COVID crisis. The scale and impact poses a real threat to a nation's survival and business continuity in companies everywhere. So that also translates to our future generation of leaders and researchers and creators, okay? Now, it also have impact significant every aspect of life, from a nation competitive advantage, enterprise, economies of operation, financial system, to society and everyday life. And we have actually experienced this today. So it's actually reshaping the world we know. So the need, the speed and the need to digitize a nation or a business or an organization has gathered greater momentum and urgency. So it is vital for all of us, including IHLs, to leverage on high performance computer technologies to help achieve innovation with agility and precision. Now, HPC, or high performance computing, is the ability to process data and perform complex calculation at high speed. It is through data that groundbreaking scientific discoveries are made, game-changing innovation are fueled, and quality of life is improved for billions of people around the globe. HPC is the foundation of scientific, industrial, and societal advancement. As of technologies like IoT, AI, 3D, simulation, the size amount of data the organization have to work with is growing exponentially. For many purposes, such as streaming live sporting event, to tracking a storm, like for example, El Nino, testing new products, analyzing stock trend, the ability to process data in a big way fast is critical for outcome accuracy. So to keep a step ahead of competition, governments, organizations need lightning speed and reliable IT infrastructure to store, analyze massive amount of data. HPC is the foundation enabler to allow a nation, a company, to achieve scientific breakthrough, to solve complex issues and challenges, as well as enabling a new generation of high-tech skilled workforce talent. So after this session, it is, as I said, we will be engaging with all of you even more to help and partner you to map out what are the next few steps in your journey. At the end of this expert sharing, we will also be sharing for my colleague, Jia Singh, on the call for educational projects, which you could submit your projects to get allocation of resources on that basis. Okay, now with that, maybe allow me now to share a bit about NSCC and the infrastructure that we have in place in today. Okay. I hope that everyone can see my screen. All right.
Yes.
So NSCC, or National Supercomputer Center of Singapore, is a NRI, which is a National Research Infrastructure funded by NRF itself. And we are a national platform that is meant to be sharing our high-tech platform to all. So it is an open to all initiative, including IHL, government agency, RIs, and industry. And we have high-speed network links connected within Singapore as well globally. And we are the first national petascale facility. So we have four main founding stakeholders, which is A-Star, NTU, NUS, SUTD, and new stakeholders like TCOM and the Meteorological Service of Singapore itself. Now, we've, as you can see here very quickly, we are funded by NRF through NRI, okay, but we are hosted and managed under ASA. That's why we are situated in Fusionopolis, as you can see here. Okay. Now, this is our steering committee. Our chairman is Mr. Peter Ho, very well-known ex-civil service head. And we also have the privilege and honor of all the esteemed professors in Singapore, from NUS, A-Star, NTU, as well as private sector, from Rolls-Royce to Deepwater Keppel Marine itself. And we have Professor Satoshi from Riken, which is the world's fastest supercomputer, as well as Professor William Group, which is the Director and Chief Scientist for the National Center for Supercomputing Application in US. We are all connected together on that basis. Now, in 2016, we actually built our first petaflop system, okay, and within itself, we have 13 petabyte of storage. As I mentioned, Infinity Band, we are all connected with, within Singapore with Infinity Band with 100 GPS. So it is a very high speed link. And very interesting is that beyond that, we also have add-on system with AI platform with 6 DGX. So especially when you're doing or interested in AI research itself, you'll be well supported with the DGX supplied by NVIDIA itself. We also have a 1000 core HTC system, as well as Copen, which is 160 teraflop. Copen itself is the climate change supercomputer for NEA itself, and they have found it very useful in using it from prediction and analyzing of weather condition itself. Now, one very interesting fact is that our supercomputer is located on the 17th floor, which is one of the highest operational supercomputer in the world. Okay, and we are using warm water cooling itself. In the same time, we are in development, and come 2021, we will have our new Aspire 2 in NU West. Okay, and this is we're going to upgrade from 1 petaflop to 10 to 20 petaflop system itself. So this enablement comes in a very good time. In other words, when this new supercomputer comes online, your school, your student, your lecturers is going to enjoy the new supercomputer itself. Okay, so this is a bit of more details as I just mentioned earlier, so I'm not going to go through in detail of this. Okay, now at the same time, the Aspire 1 and NSCC data center has various software itself. We are built on a Linux operating system. Okay, at the same time, it is based on a Q system as well. Okay, so as you can see, there are various applications that's already available that you can actually use for your research, from OpenFOAM to PyTorch, okay, as such. Okay, so if let's say you are using a specific software that you need to, we can actually more than happy to actually discuss with you in a greater details on that basis. Okay. Now, NSCC data center is, as I said, based on a combination of 3 cooling systems to achieve maximum efficiency. Okay, one is obviously liquid cooling, air cooling, and chilled water cooling. As for our new DC center, we are building one of the state-of-the-art supercomputers, okay, which is based on digital twin with multiple IoT sensors to achieve optimum efficiency, as well as it is AI assisted. We are taking our own medicine. In other words, we are doing what we are preaching as well, going down the path of using AI and new technologies to achieve optimum outcome in our operation of a supercomputer. Now, the other interesting thing that I'd like to share with you, and this is actually one of the key things where we have started to engage in the last 1-2 months with all the IHL, AI seems to be a very hot topic among all. Okay, so within our system, okay, we provide computational services that include 48 NVIDIA V100 for AI and deep application. Okay, and also provide access to Saturn V, a cluster of 125 DGX1 that will help in your especially most complex AI requirement on that basis. So as mentioned earlier, we will be inviting nomination for each school to undertake a deep learning course with us after this particular enablement, so that we can continue with you and partner with you your journey to acquire the new technological skill set for that basis. Now, one of the interesting things that, and this is something that's very possible in the future, okay, that is how we are supporting each of the stakeholders as well as users on that basis. This is the Copen climate modeling and simulation machine for NEA itself, okay? It is built for that. For any organization or any organization, thereafter, if they have substantial use of it and increasing use of it, we will be more than happy to look into various possibilities to ensure that you have perfect and smooth usage, including building a dark fiber link to your campus if you have sufficient usage. Okay, in NEA's case, we actually, because of the huge requirement, we actually have one machine just dedicated for them as well. Okay, so there are various possibilities that we could actually work with you, and we will be more than happy to engage in this discussion with you. Now, as I mentioned earlier, NSCC is actually connected to this ultra high-speed infinity band, which is the 100 Gbps. So as you can see here, our current connection is with A-Star, NUS, NTU, and SUTD. Okay, and based on the usage and requirement, if there's a significant usage in where SP, ITE, or even SIT, we will be more than happy to actually discuss a possible link when the demand justifies it on that basis. Okay, now moving on. As I mentioned to you, we are connected globally. Okay, we are connected to our US counterpart. Okay, US Internet 2 supercomputers, as well as we are connected to the European side, and to Japan, to Australia, Hong Kong itself. Now, very interestingly is that we have very strong relationship with some of the best supercomputers facilities in Singapore, such as Recon, and you will probably be receiving, or you have received some of the interesting program that we are collaborating with them, especially with Recon from Japan, which is now the world's fastest supercomputer on that basis. Okay, so really the next step, we are keen to actually work and partner you more, and we would more than happy to discuss and analyze potential HPC requirement, including building a curriculum, including building a hackathon and competition with you, including giving you advisory on your projects that you're going to submit for call for education, to jumpstart your adoption and learning from AI, CFD to that's on HPC itself. So with that, I really thank you for your time. There's the link here, which is a trial account link. I believe quite a number of you already signed up, and I really thank you for that. Do not hesitate to reach out to me, Tommy, or Vanessa. We'll be more than happy to do it. Now, before I hand over to the next speaker, I just want to say a big thank you to Vanessa and Tommy for pulling this together, and appreciate. And now, if I'm not wrong, if I'm looking at the numbers right now, we have almost 170 people in attendance. It's amazing. Thank you so much, everyone. All right, if not, let me invite the next speaker. That will be Khatib from MSc Hexagon to share real life industry use case that goes on deep dive, and how and what are key challenges they face, and what's the outcome they have achieved. Khatib?
Yes. Thank you, Bernard. Can you hear me well?
Yes, we can hear you.
Okay. Perfect. Okay. So I hope my screen is visible.
Yes, it is. Yeah.
Okay. Yeah. So first of all, thank you to NSCC for this opportunity. Thank you, Professor Tan, Bernard, Tommy, Vanessa. Thank you so much for this opportunity. I think this is a great way to connect with a lot of academicians, with a lot of researchers, and to share our experience in solving large-scale simulations, which are really computationally intensive and requires highly scalable, facility, something as the NSCC offers in the terms of HPC itself. So today I pretty much wanted to talk about engineering simulations, which are highly scalable in nature, that requires massive HPC requirements as such. Okay, so a quick look at what I'll be talking about. I'll just switch on my pointer as well. So I'll be beginning with particle dynamics. The reason why I chose particle dynamics is the first and primary reason is that it is definitely computationally intensive. Plus, I think particle dynamics is the one of the future of process industries and a lot of other medical and engineering streams. So that is the reason I have taken one example from particle dynamics. The other is large area simulations. So with smart cities, smart factories, and all the smart technologies coming into picture, it becomes really important for us to understand at a larger scale. So when I say large scale, I mean the area, the space in terms of the entire space itself. So I'll be showing few cases on that, and then some other engineering applications which may help you connect with what I mean by large scale and highly computationally intensive cases. So let me start with particle dynamics. So first of all, what do I mean by particle dynamics? That is complex particle physics, wherein we experience some amount of particle to particle interaction. Now, when I say particle to particle interaction, now this could be particle dynamics between fluids. It can be between air particles. It can be dust particles. It can be anything. I mean, so we are talking about interaction between particles. So when you see here, when there is no particle dynamics, there is no interaction that happens between two particles, whereas when there is a proper particle dynamics established, you see that they repel each other in this case. The contact forces between particles need to be simulated. That is again very essential. And then what is the volume of each particle? So the current simulation capability is so advanced that you will be able to even understand and define particle properties to the level of nanoscale. So you can exactly define the nanoscale properties in terms of volume, in terms of mass, in terms of the forces that define these particles, and so on. So as the world is progressing towards micro and nanoscale applications, I think it's very, very critical for us to really understand to the particulate level. I think a very good example now is the COVID situation. I do have a simulation done on COVID with the help of particle dynamics, which I may show to you to explain what exactly will be the power of simulating at a particulate level. The other requirement when it comes to particle dynamics is the size of particle itself implies the scale at which we simulate. Now, we are somewhere looking at a large mesh sizes because the particle sizes will be going lesser and lesser below. And then finally, coupling. Now, I think engineering has reached a stage where it cannot function alone. let us say cars. Even if we take a car nowadays, it's all integrated with multiple physics, multiple technologies. So no more car is a mechanical entity. Cars are now more of internet, it's more of autonomy, it is more of electronics, actuations, and so on. So in the same way, engineering is no more specific to field. So I feel in the future, there is nothing going to be called as mechanical engineering or electronics engineering or something of that sort, because everybody is going to learn something which is going to collaborate and couple with each other. So that is where particle dynamics or engineering simulations comes into picture, where you can simulate and identify multiple physical couplings into one single entity. Moving forward, so I've just taken an example of a fluidized bed. I think this is a very typical engineering simulation case. I think it's a textbook scenario where we are talking about fluidized bed. Now, normally fluidized bed are applied to catalytic converters, chemical reactors. They are applied to separation processes. So it's a place where you have air and solid coming into interaction with each other, and we use air. It could be hot air, it could be warm air, or it could be air at a different varying temperatures and varying velocity. Now, with the help of air, what we do is we churn the solid particles. Now, why we may do this is for multiple reasons. Just like I said, you can use it for coating purposes. Now, coating could be applied for chemical purposes. Coating can be applied for pharmaceutical purposes. And there are different other applications. Now, the same can also be applied for food processing industries and so on. So we use something called as discrete element modeling for this particular application. I've just given a brief introduction to what are we doing here. So you can see that we are using particles of the size of 4 mm in nature, and all the particles are of the same size. The density of these particles is somewhere close to 2,700 kg per meter cube. Now, that is something similar to a gravel. And this is a validation case to show you that whatever we do in the experimental methodology, now this is a paper that we have taken, and the same has been recreated into a simulation environment. I think gone are the days where people no more trust simulation, because during my earlier times of research, simulation was typically meant for less accurate applications, but nowadays we see simulation to be almost close to 95% accurate. And a lot of industries are now taking the route of simulation to reduce their prototyping requirements and increase the number of different applications they can use it for. Now, moving ahead, this was definitely a task which we took up during the current COVID scenario. We really wanted to understand the particle dynamics when it comes to an example of a mask, let us say. So now what is happening here is, if you notice, the mask is typically functioning as a cloth itself. You can see the exact behavior of this mask. And we are simulating sneezing by a typical infected patient. Now, there are two basically simulations what we are doing. One is the simulation involving humidity. That is, you are including some particles like saliva particles and so on to give the details of adding humidity into your particle dynamics. And then we are seeing what is the filtration capability of this particular mask and how much of particle does it really retain, what will be the size of particle it retains, and so on. Now, as you may notice, this definitely would be highly computationally intensive. So when I say computationally intensive, it means that these problems cannot be literally solved on your PC or on your laptops because as you may know, CFD itself is a highly HPC intensive area, and most of the CFD problems, as it becomes computationally intensive or it becomes more complex, then we always depend on HPC to speed up the simulation outcomes. Otherwise, things may go on for days and months together, whereas with the help of HPC, we simulate it within hours and minutes and so on. So just a brief look, we are simulating the sneeze velocity of 10 meters per second, and we are defining diameter of the particles. The discrete element count is somewhere around 5,000 particles at one sneeze. And you can see we have used up to 144 cores to simulate this particular process. This is a transient simulation, so it is done for one complete sneeze cycle plus the waiting time, where post sneeze the particles will move through the cloth material and come out. Now the cloth itself is modeled using particle dynamics. Okay, so this cloth model, what you see is multiple particles connected to each other to behave like a cloth. Okay, so this is not a cloth material as such. This is particles connected in terms of forces to depict the exact behavior of a cloth. So I think you all will definitely agree with me that every item in this world further divides into microscopic particles, and that is the overall nature. So we are dividing the same cloth into multiple particles and then giving it the cloth dynamics basically. So if you notice, with the usage of 144 cores and a 2 second of simulation, so the sneeze cycle is somewhere close to 2 seconds, and we are giving a CFD time step of 0.5 milliseconds. So that is, we are dividing 2 seconds further into milliseconds of 0.5 seconds in nature, and we could simulate this entire activity in 6 hours. Okay, now if we increase this 144 to higher number of cores, we will definitely be able to solve this at a much more faster rate. And I think if you look at HPC's, NSCC's HPC capabilities, then you can certainly ramp this up to 1,000 cores and so on, and bring this down to literally 2 minutes of simulation. Then multi-physics. So I spoke about combining multiple physics into one simulation. So here what you notice is there is gravel. Now this is soil dynamics. Then there is a truck in this case, which is vehicle motion dynamics. So what are we simulating here? We are simulating two physics of combining motion dynamics with soil dynamics. Now soil dynamics is simulated through discrete element model, whereas the motion dynamics is simulated through the motion dynamics software itself. So what you notice as the outcome is the presence of this gravel literally reduces the speed or the ride and handling of this vehicle. So what I mean by ride and handling is, if you notice, because of presence of this gravel, the direction of the vehicle automatically changes. It is the effect on the ride and handling of this vehicle on such a environment, right? Now, again, we are using around 144 cores. This has taken us almost 1 day to simulate this entire activity of 8 seconds. Again, with higher parallelizing capabilities, we will be able to bring this down fairly to an acceptable level of simulation time. And we are using a log normal diameter, that is, not all particles are of same size in nature. The particles are varying, which is similar to your soil dynamics itself, right? And then you can see the detailing to which we can capture. You can see once the truck goes on that, you can see the soil structure changing in the locations where that truck has moved over. So I'm talking about particle dynamics, the scalability that we have tested for two different scenarios. One is when we are increasing the degree of parallelism, how are we able to achieve speed up? Then the second is when we are increasing the particle count, because we are varying particle count from somewhere around 5,000 particles to somewhere close to maybe 1.5 million particles. Now, so what is happening is we will be eventually using more and more particles to simulate physics more accurately. So you can see as we increase the particles, the time is increasing almost linearly. Okay, now that is the reason why we need to counter this with the HPC. So we have tested one of the cases, what you earlier saw with the HPC. We do see very good speed up as we increase the number of cores, and with increase of particles and the combination of number of cores or number of HPC that we can access, we will be able to achieve better and faster results to understand this physics itself. Moving ahead, I'll quickly introduce you to large-scale simulations. First of all, let me explain to you what I mean by large-scale simulations. Now, large-scale simulations can be problems of the size of a few square meters to a few square kilometers. Now, this could be a portion of your city. This could be a portion of a certain factory. This could be an entire building. I mean, it can be anything of that nature. The second is, of course, when we talk about large-scale problems, these are going to attract large meshes. What is mesh? I'm sorry, I didn't touch upon this particular topic. So basically in CFD, we divide entire computation region or the simulation region into smaller simulation regions. Okay, so if you notice, these buildings are further meshed into smaller cubes or smaller triangles or smaller polyhedrals. Now that will help the simulation to be simplified to a smaller region. So basically it is nothing but discretization. You are converting the entire space into smaller blocks which are interconnected to each other. Okay. Now, as the mesh count increases, of course, the load of simulation increases. We are talking anywhere about 50 to 500 million mesh count or even above. And then we are talking again about volume of, multi-physics. So this is just an example of river which is flowing, and then there is a dam which is open, and then the river further flows. Now, the entire area that we are considering over here is almost close to 1 square kilometer. And since this is water, water is a complex fluid to simulate. You can notice over the period of time, the water keeps on entering different land spaces. This gives us a very clear understanding of flooding situations, maybe a scenario where your dam suddenly breaks open and how the water really gushes into the cities and so on. Maybe a tsunami. A lot of things can be studied at large scale, right? Now, going into the problem, first of all, large scale simulations are necessary to understand the flow of wind, the flow of pollution, how the dispersion of pollution happens. This is a very, very critical area of study when you are working into areas of smart city planning. Okay, there are highly polluted cities in the world now, which needs smart planning because we need to understand through simulation how the pollution is going to get into the city. How can we locate different tall structures? How can we locate residential spaces? How can we locate industrial spaces and so on, right? Now, it is very important because tall structures, I think all developing and developed countries will have certain industrial and tall structure spaces. Now, these tall structures are going to block the flow of air. And that is the reason why you will notice a lot of smog, okay, getting accumulated near these tall structures. And those are the regions where you will find lot of pollution. Okay, I come from India. I think you are already aware of the pollution situation in cities like Noida and Gurgaon. So here again, we are faced by very tall structures closely located next to the industrial sector. Now the pollution coming out of industry get blocked by these tall structures. They don't further flow ahead, and because of which you will notice a lot of pollution getting accumulated close to the tall structure. A bit about the simulation itself. We are using more than 50 million mesh counts. Plus, to add to the complexity, we are doing multi-phase simulation. That is, we are using air. We are also introducing particles. Now, these particles can be pollution particles. You can include particles coming out of vehicles. You can include particles as dust, sand, storm, so many things. I mean, if you are in UAE, you may want to simulate sandstorms. If you are wanting to do some project of tornadoes, then you can simulate tornadoes, picking up a lot of particles along with them and so on. Then we are introducing the terrain. So you can take satellite images of your terrain, integrate that terrain into the simulation to make it as realistic as possible when it comes to landscape itself, right? Effect of wind direction. So wind will not be in one direction. You can drastically simulate wind direction over time, plus the elevation effects and so on. I mean, you can do a lot of simulations. You can do a fluid structure simulation. You can include vehicular emissions. You can include fog. You can include moisture. You can include rain. You can include snow. I mean, you can make this problem as realistic as possible, and of course, these are all highly dependent on the computation infrastructure. Then the tsunami run-up itself, I think, sorry about that. Yeah. This is once again very important to understand natural calamities, catastrophe analysis, once again leading to eventually planning the city. How prepared are we when tsunami hits your cities? What type of catastrophe can you assess out of this? When I say catastrophe assessment, it is pre-strike and post-strike. So post-strike is mostly understanding what is the infrastructure damage. Pre-strike is mostly understanding how you can do a disaster response methodology. So if you know that there is going to be a tsunami, what can be your efficient disaster response method? And if you know there is going to be an infrastructure damage, then you can assess what is the infrastructure damage. Then even planning your water ingression and flow path. Yes?
Sorry, Dr. Maybe you have about 5 minutes more to run through the
slides. Yes, I think yes. So I'm almost at the end, Bernard, so I'll just quickly finish that. Again, the next area of work is daylight and sun tracking simulations. This again helps in identifying renewable energy sources. You can understand shadow effects. You can track the movement of the sun over a period of time based on ASRAE database and so on. Again, these are large-scale simulations, highly dependent on the number of HPCs. You can clearly notice the tsunami simulation, how the CPU time has reduced with increase in number of cores. So we have used up to 576 HPC cores to simulate tsunami, or even the daylight, or even the city pollution simulation. So there is a drastic CPU time reduction with increase in number of cores. Some other engineering applications like IPX certifications. Now these are computationally intensive because they involve multiphysics and channel-based flows. You can again notice the speed-up capabilities, and this is a very interesting and important field for electronic appliances, a very critical area for the future. Welding process simulations, again, a complex engineering application which is computationally intensive and makes use of CPU time. Airway manipulation, something like AI-based pneumonia pattern assessment in terms of COVID, then targeted drug delivery simulations to specific locations in your body, 3D tomography, CT scanning, a lot of these activities. And finally, the wind farm generation itself. So these are all very, very large scale. you can see we are collaborating the topography of the land to the landscape to simulate large wind farms. With this, I will end my presentation. Thank you so much for hearing out to me. Thanks for your time. And I'll be open for question and answers at the end of the session. Thank you, Bernard.
Thank you, Khatib. Thank you so much for your very insightful, very exciting. Just before I pass to NVIDIA to Nicholas, I just want to say one thing is that in quite a lot of conversation I have with potential users and new adopters is always about the question of using your desktop and email cluster computing. The challenge is don't downsize your problem statement. Okay, if possible, really use HPC to really address the real problem statement and root of the issue, rather than you downsize it and you simulate it over your desktop at a much smaller scale. You're downsizing problem. That may not be the best ideal situation. Okay. Next up, I would like to invite Nicholas from NVIDIA to share their AI examples that they have been working with industry partners. Nicholas?
Okay. Hello, everyone. Good morning. So today I'm really going to share about two areas of use cases. One is about Industry 4.0, or in general about really manufacturing and industrial use of AI. And then I'm just also going to touch briefly on especially 2020 type of use cases for smart cities and how AI can help our cities to be smarter. Industrial. Clearly, manufacturing industrial is a very wide segment, a very large number of use cases. So it actually would be oversimplification to say that it's a single industry. It's actually a wide-ranging number of industry, which typically work in manufacturing or running plants. And so in a way, they have fairly similar needs, although they can often have to be implemented in different ways. So the needs be able to optimize the end-to-end production lines across all of these different stages, of production is really huge. And there is a lot of data, there is a lot of opportunity. The question is, how can we, what are the techniques and method that we can apply to be able to help, with these many challenges. So here we have some of the trends across different aspects of manufacturing, and how can we impact them towards the, towards essentially a more proficient, more efficient, and hopefully greener as well way of doing things. And, when we look at the techniques that we can apply, I think that these five are the typical ones that we tend to deploy on as methodologies, AI methodologies to apply in this process. Now, these five are not exclusive. These are the five main areas or techniques being used. But actually, there is actually a lot more than these five. And inspection, it's rightly placed as the first example on the left, because actually one of the highest costs and time-consuming and workforce-consuming task in production line is quality inspection. Very often it has to be done by people. It's very difficult to automate, or at least in the past it was difficult to automate. It tends to be a visual task very often. And again, using humans, it can be slower, and also humans, they can also make mistakes, or let's just say that it's very difficult to have consistency, right? Because one person's versus another, they might do things slightly different. So definitely that can be a challenge, the biggest challenge, I would say, in one of the in manufacturing production lines. And then we have other areas such as, for equipment, be it from plain engines, as we see here, but even just plant. Think about Jurong Islands, oil and gas. chemical plants. There is a lot of equipment out there, and it's downtime, especially if it's not planned, can cost millions of dollars, many millions of dollars per day. So the ability to be able to predict the state of the machinery is very important. For that one, we're gonna touch on it a bit more in a second. And then, we've got the rest, right? Such as, using video analytics to monitor equipment and people and health and safety. And also try to optimize how we do the supply chain to have just in time. We don't have to stock too much. We don't have to be left without materials, and be as efficient and as precise as possible. Sort of just-in-time approach. And finally, also assistive technologies when it comes to engineers, for example, especially when they have their hands busy, being able to talk to an AI assistant, to, for example, consult a user manual for them, or be able just to ask questions instead of having to look at a document, and having AI, being able to answer based on a corpus of documents. And how do we, how do we get from these use cases to actually being able to deploy them? There's certainly two ways, right? One way is that there is a lot of free and open source tools out there. Certainly as NVIDIA, we produce quite a lot of SDKs that allow you to develop your own solution from scratch or adapt it from another solution. And as we are going to mention many, many times, the main requirement for all of this is high performance computing, because the single biggest bottleneck in being able to deploy the solution is the very large computational requirement that deep learning or AI training of models takes. Typically, the knowledge on how to do AI or the data set nowadays is a bit less of a problem. It's easier to resolve, and instead what we're seeing over and over is that the bottleneck is computation itself. And as it was just mentioned, a lot of people do things on their workstation, but then they see that it's not enough capacity. They either get tired or they're not able to get the result they expect. And unfortunately, they never really get to be able to go to production, to market, with their solution. And it's really a pity because, computation is out there. It's not a skill that has to be learned. It's just, being able to tap in the right resources. The other way, of course, also to deploy the solution is to actually tap into an ISV. So there are companies and startups that develop specific, usually very niche solution for specific use cases that you can just get off the shelf. But even in those cases, and here we've got many companies examples, even when you get off the shelf solutions, to be completely honest, companies should still have a kind of skeleton team or organization or academia skeleton team to be able to deploy the solution, to be able to evaluate the solution, if it actually meets the requirement, and also to be able to adapt the solution, because very often there are some certain specific aspect to each deployment that requires some kind of basic level of adaptation of the using transfer learning. In automotive, just to choose one particular specific industry, there is a lot of different uses of AI today, right? You go from being able to, in this case, we're looking specifically at inspection. There are actually a lot more than these 8. These 8 are just inspection, right? There is also AI be used for, teaching or guiding robots to assemble, and also to optimize supply chain, for example. But just look at inspection. You have optical inspection of the metal stamping or the casting of the parts. And very often, one of the challenges with all this visual inspection is that components can be very small, or a defect can be very small. And so for a person, sometimes they might also have to use a lens or a microscope. It might take a very long time. And be able to do that at a very high accuracy with computer vision and AI, it's very important. So some of the use cases here are, being able to read characters, right? So that you can ensure that all the codes, and the VIN number, etc., is correct. Just counting components and ensuring components are in the right place and installed in the right way, right? This also applies, for example, to semiconductor industry, right? Which literally they also check that small components on a PCB are installed correctly. Can you hear me? I just get
Nicholas, you can hear us? Hello, Nicholas. You mute
Nicholas,
yourself.
you're mute.
Nicholas, you're on mute.
I'm not on mute. I just got
Okay, you're good now.
suddenly I saw a little flag that there was an error with the audio. I have no idea what it is. Okay, let me. Okay, no idea. It just came up with a question exclamation mark on the microphone. I don't know what. Okay, can you hear me again?
Yes,
Right.
please go ahead.
Yeah, so I was saying that there is a lot of visual task in terms of the defects, missing components, and so on. And some of these, I said, the same technique. They're also used, for example, to inspect PCB in the semicon industry. But in general, visual inspection is something that is quite common across a large number of industries. A recent example I had to deal with was, for example, inspecting solar panels or inspecting wafer from semicon and also LCD panels, for TVs and monitors. All of these have a large surface area, and very often it requires a high resolution or even microscopes to be able to detect any kind of defect. And you can imagine if a person were to do that, it would really take quite a lot of time. Sorry, my computer is a bit lagging. Okay. So as I was using automotive as an example, BMW is someone that really went all the way in being able to deploy this type of solution. And it's not just about robots, building the cars. They actually have, there are things as simple as having robots that can pick up components from the warehouse and bring them close to the station of the where the person works, right, or where the robot is. There are things like this that they're quite simple, but they can really help a lot in optimizing the floor, right, and the space that is used, and the supply chain and the complexity. And here, there's a bit of a video. I hope you can see it. We have an example. And what we're doing here is one of the easiest way to be able to train these robots that move all these parts around is really to create a digital twin, a virtual environment. And so with NVIDIA, we use the same technology that are used in video games. And because the environment can be very realistic, and we create a large variety of scenarios very easily, a lot faster than we would do in a physical environment, we can then use those to train the robots to deal with different type of challenges, and then those whatever is learned can be loaded into the robot directly, and it actually can work in the real world, in the real environment. So these are some of the ways that we use AI. So it's not really coding, right? AI, we really utilize examples to be able to train models and robots to do something. So I'm going to skip this a bit forward. But it's, in this case, these are robots. You might have also seen Amazon also uses them. They're quite flat, and essentially they go below pallets, for example, or some other container type, and they can just lift them up and move them in other different places. Another example, again, not just auto, but any kind of assembly. In this case, it just uses not just visible light, but sometimes also like UV or infrared to be able to detect small gaps in assembly, and also be able to measure those gaps so that if they are beyond, higher than a certain threshold, they can be remediated, or otherwise it will just be passed. So quite a lot, these are mainly to do with inspection. But it's not just about inspection. One of the challenges in this highly automated manufacturing plants is the fact that there is a lot of robots, a lot of machines. And it's very, very important to be able to monitor this machinery and ensure that it's always working optimally to be able to reduce downtime as much as possible. So, AI is also heavily used to be able to detect different type of anomalies, not just detect that there is an anomaly, but also try to classify it. So there are models that can just detect an anomaly. They just say, they do not know what it is, but they will just tell you, things are not as they usually are. So they are essentially self-learning systems. So they just know that things are different, but they might not exactly know what's wrong. And then as data is being captured for different type of failures, for example, this kind of system are also able to specify potential type of issues with equipment. Now, this is not just something that it's been applied for when an issue arises that stops the equipment to work, but very important because we record a lot of data from different sensors, we can now see the signs that maybe a naked eye or a human would not be able to tell, but small signs that AI is able to pick up, and it can detect what are the signs that something is about to fail before it fails, right? So the early signs. And what we can do then is typically it's a lot easier to be able to schedule maintenance in a suitable window. And typically it takes less time to repair something in a ordinary maintenance rather than dealing with failed equipment that can also damage other components. Apart from the anomaly, of course, these models are typically developed using so-called lifing models, in which the life cycle of tools and how they how they wear out, it can be modeled and predicted. And also when it comes to planning how to do the maintenance when and optimizing the whole process of maintenance itself, it's something that AI from a prescriptive in a prescriptive way can help, right? Both in planning the work plan itself, and also, you literally have systems that for a plant will just pop up, and this using AI, not just using a calendar, and telling you, that you will have to go and do maintenance on a particular piece of equipment, and that you should do it at this time, and that you should do A, B, C to be able to do that, right? And essentially fill in work orders for engineers, or in some cases, robots to go and do the maintenance. So how we help in NVIDIA with this, and going back to the computation, we have a lot of SDKs, which are all free, that make it very easy and try to reduce the so-called, reinventing the wheel factor in many of the solutions. And so by using GPUs in HPC, you can first train a model. For example, if you're looking at defects, on how to detect particular defects by using example of images, for example, of something that has a defect versus something that doesn't have a defect, and then be able to train your model. And then, of course, you can also deploy it, for production. Typically, for production, you don't need HPC. The HPC is more for the DevOps, for the development of these models, and then production can actually utilize less powerful GPUs and being able to run on different type of sensor coming in with the data. So when it comes to really industrial, there's a large variety, only touch on some, but I think that inspection in general and predictive maintenance are the two top one use cases that are in highest demand, and they provide the biggest return in time and development investment. And of course, there is other more process-based optimization that AI can help, as I mentioned, with supply chain, logistics, and so on, that are also additive to all of this in being able to make more efficient end-to-end processes. So this is in very large demand, and if you're interested for your organization, or if you want to get into this, right, it's definitely a great area, because the demand for this type of solution outstrips many times the actual offer of people that develop skills and solutions for the industry. Now, that's for industry, a quick taster. And now I just want to quickly switch on the smart cities. As smart cities, some of the cases might also overlap with the industry, but there is, of course, plenty of opportunity to make our city smarter and make our life better. And again, be able to be, safer and greener as well, hopefully. Now, this encompasses both the running of the city, a lot to do is with the traffic and public transport, but some of it will also go into the retail and in stores, or as I said, in factories or public health, right? At the end of the day, the city is not just a public infrastructure, but it's really everything that we encounter in daily life in a urban environment. And so, in particular, when it comes also to public security and being able to augment or provide better way to manage, for example, traffic or queuing. These are, again, a very useful solution in these environments. We know Singapore, for example, is a very, very large city. There's a lot of people, and so being able to optimize how people move around, especially now that we have so many limitations with COVID, becomes quite important. Now, how do we, as NVIDIA, deal with that is with our Nation AI or AI Nations program. We also collaborate a lot with NSCC on this, as they are a key platform in Singapore to be able to, for developers and scientists and researchers to research and develop solutions for, the Smart Nation program of Singapore. And, oops. Okay, a bit stuck. And this essentially is our component. We have, of course, the most important, we have a lot of SDKs that we provide for to be able to deploy this solution in the easiest possible way. And of course, we have courses and other programs to enable developers in the best way to be able to do this. A lot of the companies in this are startups, and a very important program that we have is our Inception program that helps startups being able to utilize AI and accelerated computing in HPC for developing their key core offering. Now, going back to the particular solutions or use cases, of course, we have to mention COVID. This is just an example. There's actually quite a few companies now developing end-to-end solution with hardware and software to easily provide, in this case, is a solution to monitor people's temperature. And what we typically have is a dual camera, thermal plus optical, and we can combine the thermal data, which of course can automatically detect the temperature, maximum temperature on the surface of a person, and then pair that with face recognition so that we can detect the person's face, possibly match them against a database if necessary, and being able to log the temperature that they had at a particular point, right? So this becomes a lot less intrusive way to do that. A lot of people nowadays in Singapore, they just have this kind of solution, but it doesn't use AI. So it relies on a person making sure that they see that, looking at the screen. And if they turn around for a second, they might miss someone. So clearly it's, using humans, not the best solution, to be honest. That's why AI can really help a lot in making us safer, with COVID. And this is just temperature detection, but clearly there is a lot more to that. And in different type of environment, we might have different type of solution. So the one that I just showed in the previous slide would be number one, in which at entry points we just want to detect not just the body temperature. The previous solution had a 2 camera apart from the face recognition and the temperature match. It can also make sure that you're wearing a mask, for example. We have actually released AI models that can detect if you are wearing a mask or not on our NVIDIA GPU cloud, and they're free for anyone that they want them. We have a lot of these kind of models, and we just make them freely available to everyone. Something else that was already quite present before COVID, and now is even more important, is queue management. In Singapore, we already have some organization in which they use their normal CCTV cameras to be able to check queues, and they monitor the length of the queue. When the queue goes above a certain size, then it will trigger a request for someone to be able to expand the capacity at whatever kiosk or place receiving people that there is. So, and nowadays that is also being augmented by ensuring that we can calculate the social distancing. And that is also actually number 4, being able to look if people are congregating too close to each other in different areas and creating heat maps, and also social distancing. Social distancing, a very, very nice solution. When you look at them, what it will show is, I think it will be on the next slide, but it actually creates a little disc around the person as an overlay on the CCTV camera, and it ensures that people are not spending too much time, within 1 to 3 meters distance of the person. And again, it can create, usually it's not about a particular person that it will do that, but it will just find any area of a building in which they tend to see people aggregating too much, and then people can just take measures to try to avoid that in that particular area and maybe get to the cause of it. Of course, number 3, which is not just about COVID, is face recognition. Even in factories, and also in some places in Changi, where they have thousands of people every morning walking in, they want to not use, first of all, they don't want anything to touch, right? So even badges and so on, they don't want to use it anymore. So what it will create is simple corridors. You just walk in these parallel corridors, and you just work on your normal speed, and a camera will recognize your face, will essentially log that you are arrived at work at a certain time, and will open the gantry for you to come through without you having to touch anything or having to even slow your pace, right? So this type of solution are being even more accelerated now, with COVID. And of course, we have other type of solution which are not specific to COVID, but are still very important in a smart cities, such as being able to identify when there is public safety risks, such as certain behavior like fighting or detecting weapons or abandoned objects, right? So these are really one of the ways in which Singapore keeps us safe. And it doesn't come for granted. I worked on a lot of projects with the Singapore government, and they have a lot of solutions to specifically ensure public safety, so that we can all feel safe. And going back to the hospitals, now we are starting to trial also in Singapore.
Sorry, Nicholas, Tommy here. You have 5 minutes. If you
Sure, I got another 2 slides only. So yeah.
Thanks.
In Singapore, we have not just Singapore, but actually in other places of Southeast Asia, we are deploying our Clara Guardian platform. Our Clara is our platform for healthcare. As was being mentioned earlier, AI is very, very useful when it comes to medical imaging. And in fact, we also in NVIDIA, we developed some models to detect COVID-19 in chest X-rays or CTs, lung CT. But now there is a lot more, right? We have a lot more people in ICU. Now, hopefully this won't last long, but it has given an opportunity for us to accelerate the development of some key technologies, right? Patient monitoring is something that, ICU is very expensive. You have a very, very high ratio of nurses versus patient. In some cases, it can be 1-to-1. This can be very expensive. And it's also very tiring, because when you have a peak of a lot of different people, you need to keep them safe, but you also need to be realistic about how much stuff you can have. So nowadays with patient monitoring, we can have a single station which not just monitors all the vital signs of the person and the availability of medications that they may be attached to, but it will also use cameras to be able to detect if they're in distress, or if they try to get out of the bed and maybe they're gonna risk of falling and so on. So even fall prevention is a very interesting AI model that actually is able to look at detect every single joint of your body. So essentially you become a sort of stick man, and then based on that we can create a range of scenarios in which clearly if the stick man is lying on the floor, then is horizontal, something might be wrong, right? So there is quite a lot that we can do with that in the hospital environment. Of course, we already talked about the temperature monitoring, the social distancing by being able to calculate distance between people in a CCTV scene. A lot more, as we're talking about contactless access controls. Now in the hospital, we have even more contactless, even just to interact with computers, right? So similar to what used to be used Microsoft Kinect a few years ago, we are now using similar technology, even just with normal cameras that can look at the hand gesture of a physician, and this way they are able to control a large display, for example, in an operating theater, when they, they're operating on someone. When we see here surgeon analytics, that one refers to the fact that it might be interesting, but one of the biggest challenges in surgery is the very high risk that instruments or gaze, etc., might be left inside the body. And now we have cameras monitoring that and counting the instruments and counting the gazes, which in the past has always been a job of one of the theater nurses, right? But again, they're under a lot of stress. So we do need assistive technology to be able to help with that. And they will just count everything and try to, ensure then that the count that they use, matches the count of what is left over after surgery, so that everything is accounted for. In retail, clearly we see a lot of changes in our daily life as well. We, a lot of limitations on how many people can be in any room, in any space at any one time. So, avoiding crowding, and again, ensuring that people are wearing masks or other PPE is very key. But at the same time, we also need retail, especially now that they're being challenged so much by everything that is happening, to be even more effective, right? We have seen a large move towards online retail, right? But physical stores still have their value. And so physical stores, if we can see something positive in COVID, seen a push in adopting certain technologies to ensure that their efficiency is high, so that they can maximize the revenue and also try to keep costs in check, right? And so store analytics is something very key. I also work on a lot of these projects, and the way it works is that we just utilize normal CCTV cameras that any store will have for normal safety reasons, and then we feed them into a system with GPUs and AI models, and they're able to run a large variety of analytics. They can be just, checking if people are stealing stuff, to be honest, but it can also do, more historical and long-term analysis of, for example, creating a heat map to see where people spend most of the time inside the store, so that you know how to position products in a way to have better visibility. You can also see how people, for COVID, where they're crowding because of how you lay out the store and optimize the layout. You can create a store without people, similar to what Amazon did. You just take the stuff, you walk away. You don't need to have people manning the store with the risk of them getting infected. And you can have some of this kiosk store. I think one was opened on Orchard Road recently. You only have one person at a time. They enter, they can do their store, and then they exit. They don't have to share the environment with anyone else. And of course, there is many other things, such as doing face recognition, not really to identify people as name and last name, but more to be able to identify if you have always new customer, or you have like fidelity, right? And you have repeating customers. And there are many supermarkets now simply using CCTV cameras to monitor the shelves, right? People in a store are often tasked every few minutes to have to go around and check stock to ensure that everything is still on the shelves. These are a lot of repetitive tasks that, to be honest, could be given to AI rather to a person. People can be used for more added value type of tasks. And so CCTV are also used, and also robot that can go around store. They can actually identify, out of stock for particular products, and which product it is by scanning the label and be able to create a list of restocking or even just place orders, right, to restock those particular products, right? So really quite a lot out there. COVID-19, public safety, and both for a health perspective and also for perhaps, crime or other type of issues. And finally, also how to help retail and stores be more efficient in the way they do things, so that, the economy can recover faster now. Lots of uses for AI. The key thing that you need to understand is a lot of these technologies for AI is not too difficult. I know it might seem all very complex. Actually, there is a lot of tools that we develop to make it very easy for you to be able to make this solution into reality. So the skill set to be able to develop and deploy this are not necessarily the biggest bottleneck, because a lot of tools already exist and you only have to adapt solutions. You don't have to create everything from scratch. The second thing is the data nowadays. We have large data set for everything, right? So AI depends on data to be able to train model, right? You need examples for things. Nowadays, we have a lot of data, right? And also we have a lot of tools that can make it very easy for you to produce data set, accurate data set efficiently. So
Nicholas,
the third factor, yeah.
If you can quickly wrap it up, because I think we have a few questions in the Q&A as well.
Sure,
right, thanks.
sure. And the third factor, which is my last point, is that, if the first two I already mentioned that they are, they're not a particular problem. The third factor, which is the biggest bottleneck, as I mentioned earlier, is compute. So, we have to accept the fact that this technique requires a lot of compute, but although it might be an investment, although it might require HPC, it can provide huge benefit to any user, any organization, right? So as it was mentioned earlier, do not scale down your problem. AI requires computation, requires to use very complex model to be able to be truly useful. Otherwise, it won't be useful, and it won't have the accuracy required for you to deploy to production. So, please use, what is required. Don't oversimplify, because otherwise it might not be so attractive. It will not be so intelligent anymore, let's put it that way, right? So we need AI to be very intelligent. If it's not so intelligent, then perhaps it's not going to be as useful for us.
All right,
for me.
Nicholas,
Thanks.
Thank you so much for your insights, very valuable. I know that we're running out of time. So if later on we can't answer all your questions, quite a fair bit of question, my sincere apologies for that. I would like to quickly invite my colleague Jia Xing to share on the call for educational project that's upcoming, that all the IHL can subject a project request, and we can allocate HPC resources to your project. Okay, Jia Xing?
Hi, yes, please just let me share my screen.
Nicholas, can you stop sharing your screen?
Oh, yeah, sorry. In the questions, can I already answer them? Because I see the question, but I'm not able to answer them.
No, we will do the Jia Xing one first.
Okay, all right.
Yeah.
Hello, yes, can everybody see my slides?
Yes.
Okay, yes, so after hearing so many users for NSCC resources, you will need a project in order to use. And let me just quickly run through. We have this call for educational project in NSCC. Currently, it is only open to polys and universities. So IT folks, don't worry, we will have something else later on from Tommy. And this call for educational project is to support any educational related purposes, such as teaching modules, courses, competitions, or any workshops. And our upcoming application will be in October, which is for resources from February to January, a 1-year period. So if any of you are interested, you can look out for our announcements coming up. And the application can be made through the online application form as shown. And all these applications will be reviewed by our Educational HPC Project Evaluation Committee, which comprises of reps from all the IHLs from various IHLs, so you don't have to worry about this. And also, other than the educational project, we do have a special call for COVID-19 research, and this application is open from now until 23rd of September, but no worries, there are plans to extend this beyond 23rd of September, so you all can still look out for this if you are interested for any COVID-related research. If you are interested, please just apply through this link. All applications for the COVID project would get priority in their job submissions because we want to encourage people in their COVID research. And this call is open to everybody, no matter you are from polys, ITEs, or industry users. Just feel free to apply if you have the need for it. And next, Tommy.
Right, thank you, Jiaxing. Like what Jiaxing mentioned, the call for educational projects currently is more for polytechnics and universities. However, it actually depends really on the response of the ITEs. Here, IT participants can actually apply for 3 free trial accounts at this website, which was also shared by Bernard in his last slide. And it is worth 3 months complimentary basic plan worth about $1,500. If the response is very good, we would evaluate and in a management level to see if this can extend to the call for educational projects. Yeah, that's all. Thank you.
All right, thank you, Okay, so I think we're almost time, but I think if you guys don't mind, I'll just sneak in 2 questions. One for Khatib and one for Nicholas. One of them is for Khatib. For large-scale simulation, can I know what to use for simulation? Is there a possibility to create API to link 3D packages? Khatib?
Yes, so the API linkage is possible. We also have, from the software point of view, the API and MPI are already integrated into the Solver packages. Yeah.
Okay. The other question is for Nicholas. Can AI be trained to be integrated into another software? Nicholas?
Yes. Yeah. So absolutely right. The way that AI works is we have libraries or frameworks, and these frameworks allow you to package the AI function in many different ways, right? So one way can be to embed as part of an application. Now, to be completely honest, so people can essentially put inside an app on a phone. So they can put inside a Windows or Linux application. But the most common way to actually do the application, if the application, for example, is a web-based or online application, is that we have tools to create microservices that typically run on top of Kubernetes. And these microservices will have all the AI model inside. And then your front-end application, your main application that does everything, at the time they will need to do anything that requires AI, it will make a back-end call via REST or Google RPC Web Services Protocol to the microservice. Let's say sending a picture for an app to validate your identity against your NRIC, right? It will send just your picture, and then it will get an answer back, and then it can continue to do what it needs. One of the reasons that we like to decouple this is because cloud native approach, which is very compatible with AI, requires all components to be microservices that talk to each other using web services. And the second reason is that AI, even to do the deployment phase, so not the development or training of the model, but the deployment, which we call inferencing, requires often GPUs, while your main application maybe that might not require GPU. So because of that, we also try to decouple the two applications.
Okay, great, thank you. Well, we still have quite a lot of questions. Unfortunately, we can't answer every because we don't want to take up your time. It's until 11:30. feel free to email us to Tommy, myself, and Vanessa, and we will be more than happy to help you facilitate some of the questions that you may have with the experts. And we will then definitely more than happy to answer for you. So look out for our next email that we'll be sending out to invite you for the next enablement session on the 23rd for social science and economics. So that's something that to look forward to. If not, I will not waste anybody's time anymore, but really thank you so much for all your participation and precious time, and I appreciate all your time that you attended. Thank you, and everyone stay safe and have a nice day ahead, all right?